Hello everyone and welcome to this Tech Excellence meetup. Our vision is to raise the bar of technical excellence across the world. And here is an overview of our speakers for this year. So please make sure that you've joined us on Meetup so that you can get notifications about our future events, and also feel free to like this video and subscribe to YouTube. Also, you can follow us on LinkedIn and Twitter to stay up to date with our events. Now, for today, I'm really excited to announce that Alex Bunardzic will be joining us to talk about agility, which is an often misunderstood topic. So the topic here is that Agile is a slow and steady way to win the race. And also I want to mention that Alex is the director of automation at Digital Expert. So I'm really happy that we will have this opportunity to learn a lot from him today. So Alex, feel free to share the stage.
Thank you, Valentina, and hi everyone. Just to answer the question, to win which race, and I want to say we're trying to win the race against our own incompetence or lack of ability to deliver to the expectations. Let me start by first a few words about me. And Valentina, I hope that I'm advancing in the slides. You can see the next slide, right? Just to confirm. All right, silence means it's working.
Sorry, yes, I unmuted myself. Yes,
I know. Okay, about me. I'm making a living by selling technical excellence. And in my experience, it is one of the toughest jobs, maybe almost as hard as selling life insurance. So why is it so hard? Because everybody wants it, but nobody likes to pay for it. So everybody would like to be insured, but the premiums are high, and everybody would like to have technical excellence, but it means certain investment. So before we start, I just want to give a quick summary of what we're looking at, and then we go into more details. Technical excellence does not come cheap. It requires a lot of investment. It's, on the other hand, it's assumed by the paying customers. And it's normal, because if I'm buying anything, if I'm buying a car, I'm assuming that this product is in excellent shape. I'm not going to pick it apart and examine. I trust, that what I'm buying is already excellent. But in software, and not only software, but like technical excellence is often invisible. It's under the hood. We don't see it. As a paying customer, so in software, there is a tendency sometimes to skip on technical excellence because nobody sees it, and whether it's there or not, paying customers don't know it, and then they won't even complain. For example, if I'm manufacturing a new model of automobile, and part of the technical excellence would be to implement airbags for safety. But you see, like, I had many cars and I've never actually seen an airbag, and I hope I never get to see it ever in my life. I don't want to be in a collision. And so I'm assuming that the airbag is there inside, and God forbid it will work if something happens. But if I'm a car manufacturer, I may think, look, adding airbags is actually adding to our cost of production. So maybe we just skip on that. Nobody will hopefully notice. But luckily, there are government regulations that prohibits me from putting that product on the market. So even though it cannot be seen by the customers, it can be seen by the inspectors. And so I'm forced to put it in. However, in software, there is no such regulation. And we then are tempted to say, okay, we can skip on that. We can, nobody's going to notice. There's no regulation. And we have some initial savings, but these are deceptive because there's a price to pay for cutting corners, and this price is cumulative. And then when things start falling apart, then we are in big trouble. So today's presentation is the recommended way to avoid cutting corners is if we adopt the Agile practices, then we will be spared this temptation, hopefully, to paint ourselves in a corner. Agile approach to building and shipping software, as we've seen, seems to be the mainstream now. Every company I ever consult with or work with appears to be transitioning from waterfall to Agile processes. So it's very popular. No denying. I want to talk about some misconceptions about the Agile process, because there's few. The first one is that Agile means sprinting. And a lot of people, when we talk about Agile, so what do you mean Agile? Well, we're going to be now having regular sprints. And in people's mind, that immediately means, okay, we'll be now going really fast. So the first misconception is that we will be exerting ourselves to create and ship software as fast as possible. So it's just this kind of a mad speed. The second misconception I'm seeing is that Agile means we can liberally cut corners because we're rushing to meet market and customer demands. Just whatever, cobble something up, some spaghetti code, and just throw it out on the market. That's what Agile means. And this is a misconception because there are no shortcuts to any place worth going. And if we're making shortcuts, then probably we basically paint ourselves in the corner pretty quickly. The third misconception is that Agile means ignoring the importance of building and delivering technically sound systems. Because in the early days, and even today, a lot of startups were doing some trivial things. Hey, here's my app where you can share pictures of your cats. And it doesn't have to be super duper technically sound. And even if something doesn't work, well, too bad, you lost a photo of your cat. You can upload it again. But that's a misconception. Because Morpheus can tell us that if you throw enough mud at the wall, eventually it gets deducted from your security deposit. So this is, again, the cumulative price we end up paying, which is not good. And the fourth misconception is that Agile is nothing but repackaged traditional waterfall process, where a single waterfall now is replaced with a series of mini waterfalls. So we call it Wagile sometimes. So oftentimes I'm noticing that when we are faced with some new or unfamiliar concept or practice, then we try to drag it down to our familiar level, something that we already understand. And say, look, it's just another word for something I'm already doing and I'm already familiar with. Or as the most interesting man in the world says, I don't always do Agile, but when I do it like waterfall. Let's debunk some of these misconceptions about the Agile process. So my most famous, most favorite slogan or mantra is sooner, not faster. So I always keep repeating that. And I think it's a very useful mnemonic and very useful formula to keep in mind when we're trying to enter the Agile world. So instead of focusing on increasing the speed, we should focus on arriving sooner. And, when people speed through rush hour traffic, speeding is always unnerving and basically not a prudent approach to doing anything. But sometimes there's a confusion, and increasing frequency, meaning delivering things sooner, does not mean that we are increasing the speed. And sometimes these things are counterintuitive, and I see people sometimes confuse the two, and I think they're one and the same thing. So I'll try to explain later. So how do we slow down and yet arrive sooner? That sounds a little bit contradictory and confusing. It's almost like, we're talking paradoxes. I want to quote Mary Catherine Bateson, who I believe she's the Gregory Bateson's daughter. And if you haven't read Gregory Bateson, I really recommend reading his Steps to an Ecology of Mind, really great book. So she says, the human species thinks in metaphors and learns through stories. And with that in mind, I want to ask you to sit down and allow me to tell you a story. With the story, I'm trying to illustrate some of the concept. So suppose you're running a busy restaurant kitchen and you have your great staff gathered together. And then one day, out of the blue, a famous food critic calls and announces that he will arrive with his friends for dinner, excuse me, in an hour. Wow, so that's a very significant event because you want to amplify your brand. And if you get favorable review, then you may get more patrons and your business will grow. So you're super excited. That's great news. And of course, you decide to prepare no less than full-blown 5-course dinner for the critics party, and you're really hoping to impress them to get favorable reviews. But the clock is ticking. You have only 1 hour left. So now you are in a tight spot. So you have the dilemma: how do I organize the work to get it done and get great reviews? The first thing that comes to mind usually is we have resources and now we want to maximize their utilization. This is all about productivity and team utilization. Let's start cracking. So you get every staff member to work in isolation on one course because the clock is ticking. You say, okay, look, we have a lot of things to accomplish and let's hurry up. And the approach is called divide and conquer, and it is time tested and proven, and it works. So why not go that way? So let me just you assign one team member to work on making the appetizers, and you assign another team member to start making soup, another team member responsible for making the main course, another team member responsible for making the salads, and another team member is responsible for making the dessert. Excuse me. So here you have your 5-course meal. You send them to work in isolation and work in parallel. And that way seems like a great way to maximize resource utilization. Sounds great. We also call that scatter gather. So everybody goes away and works on their assigned dish. They scatter and work in isolation. Then they'll get back together and work to assemble the 5-course dinner. And that's a pretty clear vision of what we're trying to accomplish. Because now this is what we are sprinting. We have 5 sprinters here, everybody in their own lane, going as fast as they can to meet the goal. So what could go wrong? Well, the problem is in the need for speed, because when we are rushing and we have a hard deadline, we can't help it but cut corners. We're using the duct tape, we're just kind of winging it. And that is not good, because by cutting corners, we know that we'll be caught, because this food critic will definitely detect that we are cheating, that we have rushed things, and it's not impressive. So we need to scratch the plan A and we need to drop to plan B. So what will the plan B looking like? So the trick is in reducing the batch size. So instead of having this big batch with 5 items, we should take only one course, for example, appetizers, and then deploy the entire team to work on it to get it done properly. So no cutting corners. And because this batch is smaller, it will get done and delivered sooner. So we are moving sooner, not faster. And by the time the guests arrive, we already finished making the appetizers, and the soup is on its way too, so we can immediately start serving them. So they're not waiting, and this is being done sooner. And then by the time guests are finished with appetizers, we are ready with the soup. Meanwhile, the team is working back in the kitchen on the main course. And they're not rushing because the guests are busy enjoying their appetizers and soup, so they can take their time and do everything properly. And then while the guests are enjoying the main course, the team is preparing the salads and desserts and so on. The party gets to serve the amazing 5-course dinner, and it was made with utmost care by the whole team without cutting corners. So things work out smoothly. The party is impressed, the critic is impressed. No one on the team was forced to rush and cut corners. You got it. Stellar reviews, and your business is now booming. And sorry, that's the end of the story. I hope it made sense. So now I want to examine some terminology here, with your permission. First, let's look at the batch. What is a batch? A batch is a group of items that move together to the next step in the process. In this case, we have a batch called 5-course dinner, and it includes the appetizer, the soup, main course, salads, and dessert. So that's a batch. There's also something called transaction cost that to be taken into consideration, which is the cost associated with shipping. And in our example, this is the cost of carrying the 5-course dinner from the kitchen to the guest table. There's also something called holding cost, and that cost is associated with delaying the shipping. What that means is we are delaying the feedback. Excuse me. And in our example, the cost of making the guests wait until the batch is all done and ready for soliciting feedback. And if they keep waiting and waiting, they become more and more antsy, and they become less and less enthused. And also, by the time we solicit feedback, they may be a bit annoyed. So let's look at what happens when we optimize for transaction cost, meaning we want to keep it low. We tend to favor huge batches. For example, hey, if we can arrange things so we make only one trip from the kitchen to the table, that is, we optimize the transaction cost. And in the case of software releases, if we, deploy only once per year, hey, that's much cheaper than deploying every day, much less involved and need less staff. Now, what happens when we optimize for avoiding the holding cost? Then we tend to favor micro batches. In our example, we are eager to serve only one constituent part of the appetizer, maybe only bread basket, but no buttery spread. So we are rushing to put something in front of the customer, and sometimes we call it micro batches. We then strive to amplify the feedback. How do you like our bread? But it's maybe too early because maybe they only want to try our bread with butter or with some spread on it, or with some dips. So in reality, there's got to be an optimum for us to find between the cost and the batch size. And as you can see in this diagram, as the cost is rising and the batch size is growing, the holding cost is linear, but the transaction cost drops dramatically with the batch size. And then the overall cost, you can see this kind of a sagging line, the blue line, where there's an optimal batch size for as the batch size is growing, we get to the point where it makes sense to start shipping, and then if it gets even bigger, then the overall cost goes up. So the optimal strategy would be to minimize the batch size until the transaction cost makes smaller batches inefficient or too expensive. And we should therefore invest as much as possible in obtaining skills that enable us to work in small batches. So that's a critical component here. For that, the best, in my experience, practice is what we call the vertical user story slicing. So instead of working on creating the entire cake, the big batch, we slice it, and maybe we first create just a slice that allows manual payment for the order, but the simple one. And then after that, we move on to the slice that allows paying with credit card, and then with PayPal, and Apple Pay and Google Wallet, etc. So eventually we assemble the entire cake. But this vertical user story slicing is our best weapon for keeping the batches smaller, and then we can manage the other, optimize it for other costs. Now, if we detected we've already reached the optimal batch size for our current transaction cost, but still we are seeing the same problems, then the next step is to invest in lowering the transaction cost. And that's also very important because, there's always a way to lower the transaction cost. So small batches are for the win. Why? Because they give us faster feedback. The customer value gets delivered sooner. They reduce direct cost and reduce deployment risk. The smaller the batch, the lower the risk. They reduce the possibility of errors and also reduce the mean time to recover. In case the errors occur, it's much quicker to recover if we have just added a small batch, and improve psychological safety. Now, large batches have serious downsides, and I want to quickly list them here. When we are working with large batches, there's lots of multitasking, and this is causing the loss in productivity and focus. The normal flow of work is frequently interrupted with problems that come from previous deployments. Low psychological safety is caused by the increased probability of outages, so we're all kind of walking on eggshells, feeling a bit insecure. And this is worsening the quality of product decisions because there are fewer opportunities to get fast feedback or to design new experiments to get more feedback. So these are all serious downsides of large batches. Also, there's lack of collective ownership, and that's also a problem. Now, another hurdle here is what I call a bloated work in progress buffer. And let's start with saying, like, I think everybody wants to be busy in our daily work lives. We all need to feel that we are contributing value to the lives of others. This is, I think, what gives us job satisfaction. But in any ambitious company, there's always so much to do, and it's pretty much guaranteed everybody will be busy all the time, and even super busy. So then what is the problem? Why are we talking about this? The problem is exactly in these things, delays and blockages. So yes, I'm busy, I'm working on something, and all of a sudden there's a blockage. I'm blocked, I'm waiting on something, and now I'm idle. And as the saying goes, the hardest work is to go idle. It is kind of unbearable. We become very antsy and nervous and anxious, waiting. So, but if one item is blocked, hey, there's plenty of other useful things to do. And then we're like, hey, let me go back to the backlog and see if there's something ready for development and I can jump on that. Makes sense. And problem is solved, but not so fast. Why? Because if we pull in a new task, we increase the work in progress. And that may not seem like a big deal, but it is. So why is increasing the work in progress not desirable? Let's look at some consequences of increasing the work in progress. When we add more things in our current pile of things we're working on, our throughput goes down. We slow down, right? Because now there's yet another thing to work on and to multitask. And our time to deliver goes up. It takes longer. The time to realize benefits goes up because you're waiting for all these things to get done. The outcomes go down. With that, the morale goes down because we're not showing much progress. We're starting to get nervous. The opacity goes up. Now we are covering up. We're like, okay, no, I don't want to look bad. And we are kind of keeping some things on the side of the desk. So that causes the confidence to go down, or lack of confidence going up. Now that mounts some distrust. We say, okay, do these guys even, are they capable of delivering something? And eventually we get to a point where we start, there's a danger of losing some key players who get frustrated and they're looking to leave and go work somewhere where it makes more sense to work on things. Let's look at consequences of outcomes going down. When we are not showing much progress in outcomes, then the pressure starts mounting for short-term results. Just show me something, right? Show me that you are working on something. This now rewards outputs over outcomes. So instead of looking at the desired impact, we start looking at number of lines of code, number of tests written, number of bugs fixed, number of story points delivered, etc., etc. So these are all outputs. And that rewards people being busy. So if you can indicate busyness and you're executing, then the bosses are happy. Immediately, we start valuing higher resource utilization. We're optimizing for resource utilizations. Everybody has to have their plates full all the time. This encourages upfront planning because now the management have to sit down and figure out, okay, how do we make sure the next quarter everybody's constantly busy? We cannot afford people being idle. Now, this creates emergence of local agendas. And back channels get created. There's all these private Slack channels. People are trying to find a workaround to get something done. The focus, of course, goes down because now we're juggling all these balls and back and forth, multitasking. And as focus goes down, the outcomes go down. And now we're looking at a vicious circle. It's like self-reinforcing. And as back channels go up, the work in progress go up as well, because all these back channels are now sparking new work items. Okay, how about this? Work on this, work on that. And the work in progress, as work in progress goes up, the number of dependencies go up, because now all these things are depending on each other, which then means we need to hire more coordinators to manage those dependencies, because they're not going to manage themselves. And as number of coordinators go up, we get more cooks in the kitchen, and many chefs spoil the broth, and now we get more local agendas. So the question is, how do we reduce, minimize, or even remove this vicious circle, because it's really a downward spiraling? And the answer is simple: limit the work in progress. It's very simple, easy to say, hard to do. Let's go back to our story. How did the team switch to the Agile process? Basically, they abandoned the initial big batch approach and sliced the batch to 5 smaller batches. And then they also limited their work in progress, and the team was always working on one thing only. They were not scattering, spreading around. They replaced asynchronous working model, meaning working on different things in parallel at the same time, with synchronous working model, which means they're working sequentially, one thing at a time only. That way, they were able to deliver value sooner without having to speed up, and that's very critical. Frequency of delivery, sooner rather than faster. And that's pretty much the magic formula that we are discovering works really well. And again, I'm going to repeat, it's very easy to mention this formula. It's very hard to put it in practice for various reasons. And what is the cost of doing things that way? It requires something we call T-shaped skills. So not only do we have experts on the team who are subject matter experts and have the depth of expertise in one narrow area, but also we are expecting now these experts to broaden their horizon and reach some cross-discipline competence, which of course it will be shallow, but nevertheless, it comes in really handy when we're working together. And there is something called transaction cost. I won't bother you with this reading, but again, the consideration here is how much does it cost if we are now working on one thing only and we are delivering sooner? This shipment, the shipping of our delivered small batch. Yes, because there is a cost associated with it, and the more often we ship, the deeper are the cuts into our profit margins. Because, for example, in our restaurant example, not only is it time-consuming and risky to carry the plates from the kitchen to the tables all the time, also we need to train, manage, retain waiting staff, and it comes at certain cost. And now the question is, can we crank it up? Can we kind of make it more efficient? And of course, in our line of work, the answer is always automation. Automation is relatively cheap. So, for example, I don't know if you've seen in Japanese restaurants this carousel model where the kitchen staff is making small batches in front of the customers, And whenever the small dish is ready, put it on a carousel. It's automatically moving, and then customers just pick whatever they want to consume. And that way, the cost, transaction cost is like reduced to zero pretty much, other than this cost of having this carousel working and being maintained, but you don't need waiting staff or anything like that. So that's one way to really balance that small batches with the transaction cost. In our case, something called continuous delivery is a fantastic discipline. Dave Farley is the inventor, basically, and the main spokesperson, and I really recommend watching many of his videos where he in-depth describes all the benefits and the issues with continuous delivery. But that's the way really to get a leg up and get into the agile mode. Continuous delivery is basically slow and steady way to win the race. Now we reached the intermission. I want to talk about some more things, but I just want to ask Valentina, is how we're on time? Is everything okay?
Yes, so everything is fine. I mean, after you finish with your presentation, I have some discussion points. So that will be for the next 30 minutes. We have the time for the session, and then after that, there's Q&A. So
thank you. So we have time for more slides.
Yes, definitely 30 more minutes. Yeah.
Oh, okay. Yeah, I was rushing. I didn't want to cut too much into them.
No,
Anyway,
no,
let me
it's
then.
great. I really enjoyed watching everything up to now and the whole analogy and visuals. So yeah, great presentation.
Thank you. I hope I'm not. Sometimes people complain like you have too many like memes and cartoons, but sometimes it helps, right? We don't want to be just dry and just text. Okay, thank you. I'll continue now. Thank you, everyone.
Yes.
So I want to talk a little bit about static versus dynamic, and to me that's very important. And we are right now, I believe, almost at this kind of tipping point in our practice and pretty much in our lives, where I think we are making the transition from the old world static views and being pushed more into the dynamic. And oftentimes, myself including, and my teams and whatnot, we feel like we are not really clear what's going on, and this dynamic world is a brave new world, but it's very, very challenging. And I feel that oftentimes I'm falling back on my static ways, just spontaneously. It's like a safety net or familiar territory, and the dynamic is always breathtaking and unnerving. It's like walking on a tightrope. But like it or not, that's where we're being willy-nilly pushed on, whether we like it or not. Nobody's asking us. That's how the world is unfolding. So this will have also impact on, I think, this discussion on agile. The very word agile in my mind, evokes dynamic. So I want to first talk a little bit about what I mean by static. There's something called the finality constraint, and I'll explain what it means, where basically we have a problem and it's fully understood, and we will not attempt the solution unless we all agree that we have fully understood the problem. And then we formulate requirements because we understand the problem, and then we freeze those requirements and they're final. And this is the finality constraint. Like, okay, we know exactly what we want, we know exactly in what shape, and we have now formulated the blueprint. It's like when you're building a house, you know exactly what you want, how many bedrooms and how many bathrooms, etc., the layout. You have your blueprint signed off, freeze, onto people to build it, and no more changes. Also, scope freeze. Please don't add another room. Please don't, this is it. Everybody agrees, fine, thumbs up. Then in our profession, we're implementing via code, and then we hit this point where we have the code complete. And you often hear teams say, okay, I'm code complete, code freeze, no more changes to the code. And we arrive at a solution, and the solution is final. And we just, okay, thank you very much. We get paid. On to the next challenge. This is now settled. The house is built. You can move in. Everybody happy. There's also one thing called definition of done. So up front, we have the crystal ball. We can see what done looks like. We can define it, and then the acceptance criteria is like, okay, let me compare with the definition of done. The acceptance criteria, yes, everything is exactly how we discussed. I'm happy, I'm paying your invoice. So that to me is what I mean by static. And this is, this is how we live. I take my car to the mechanic and blah, blah, blah. They show me what to diagnose the problem, and we agree on blah, blah, blah. And then they deliver and everything is working. So it's final fix, finality for the time being. Dynamic is basically characterized by continuous experimentation. This is really unnerving, right? Because like, why are we continuously experimenting? And associated with that is the continuous learning. While in static, there's nothing to learn. I mean, once we understood the problem, that's it. There's no more learning. And that also involves continuous innovation. So we cannot just use prefab things. Okay, we know exactly last time we did it this way, and we can now do it the exact same way this time, and it will work. No, we are challenged with we have to find another way. And that way is not forthcoming. You cannot read about it. You cannot go to the university or watch the video. You need to figure it out on your own. So very unnerving. Things are never done unless we decommission them. So especially in software, the code is never complete. It's constantly being worked on, experimentation, refactoring, etc. And we have to make ourselves interruptible. Why? Because we need to be steerable. Because in the dynamic world, unlike in the static world where you have you charted your course and now you're in flight and there's no need to steer anything. You're going directly straight as an arrow, hitting the mark, the target. In the dynamic world, things change. And if I'm in flight and if meanwhile something changed and my target, the goalposts have moved and the target is not there, if I'm not interruptible, I will be missing the mark. I'll be just wasting time just going this direction, and just when I reach there, it's nothing there. And also, as I'm in flight, I cannot be steered. The only way to steer is to interrupt. If you cannot interrupt, you cannot steer. You cannot turn the steering wheel. So these are the dynamic things. And one thing when I talk about this, everybody gets really flustered and nervous is with this interruptible. Because people say, oh, come on, I hate interruptions. And the best way to kill the morale and the best way to kibosh the project is to create a situation where I'm being constantly interrupted with emails, with phone calls, with meetings and ceremonies and all these other unpredictable things. And that is really killing the flow. So why are you advising being interruptible? And so there's a nuance here. There's a difference. Yes, I absolutely agree. I mean, if you're heads down working on something and there's all these other distractions and the government is asking you to pay do taxes and whatnot, of course it's going to kill the flow. But what I mean by that is like when I'm driving and when I step on a brake, I am not interrupting the driving. I'm still driving. I'm interrupting the certain velocity or the switching from the gas pedal onto the brake pedal, but it's still driving. And so, for example, in software development, if I'm coding and then I interrupt my coding by running tests, I'm still developing. So that type of interruption is very desirable. And the more frequently I interrupt my coding by running tests, the better chances I have for reaching technical excellence. But if I'm saying, look, I'm coding and I don't want anything to interrupt me, I'll be spending a few days just writing code here, that is a much riskier proposition. So I'm advising interruptibility in software development. And the sooner and more frequent, the better. I'm pretty much now at the point, I use something called TCR technique, where anytime I make a diff, all the tests run, they interrupt me. And then if anything breaks, it just kind of reverts to the previous healthy state of the code. So that way, I'm really ensuring that at any point in time, my system that I'm working on is up and running. It is not broken. So that's what I mean by interruptible and steerable. We should be within the context of our work. We should be able to find ways to interrupt and do quick checks, etc. I hope this making sense, because oftentimes people are really, really flustered when I say this. Like, no, I don't want to be interrupted. All right, on to the new shocking image. What is this? So, a big boulder up in the sky. I couldn't find a more meaningful image, but imagine we have a huge boulder and we somehow lift it up to a very tall building like Empire State Building or whatever, and we push it down and it's falling. Now imagine if we do the same with just a bag of little pebbles, push it off the same building. The question is, which is more likely to survive hitting the hard surface without breaking? And we know that if the big boulder hits the pavement, it's going to splinter into millions of little pieces. So it's just going to break. While the pebbles will just get around, but they're not going to break probably. So we're talking about stress here. And Agile is also all about stress. We know that software systems are constantly under stress. They are very complex systems. It's very hard to create a super simple software system. And then, in the operation and enduring constant changes, there's a lot of stress. And so we need to address that stress. First of all, when we design systems, we want to make sure they survive stress, because stress is given. It's not if it's going to happen, it's just when and how often. And for that, I see three possible system architectures that are guaranteed or can survive stress. The first one is what I call robust architecture. The second one I call nimble architecture. And the third one I call anti-fragile architecture. Let's look at the robust architecture. I use the image of this rhinoceros. A rhinoceros can handle adversity. Like if you charge at the rhinoceros and try and push him, maybe you upset its balance, but quickly he bounces back and he stays the same. You cannot harm him, and so that we say that this is a robust system. You put stress on it, it may just kind of be a little bit unsettled and then quickly bounces back, same as before. Super reliable. The nimble architecture is different. It handles adversity not by bouncing back, but by constantly moving and adapting rapidly. It's a shape shifting. It's really fast and nimble, and it can take the punch, roll with the punch, and okay, it survives. And the third one is anti-fragile, which grows and improves from external shocks. So you push it outside of the comfort zone, not only is it surviving, it actually grows and gets better under the stress or external shocks. So this to me is the most interesting architecture, and I think this is the challenge that Agile practices should take on, because we want to indeed not only create systems that are robust or nimble, but we want systems that grow stronger and stronger. And my favorite example was Netflix, when they invented a whole new technology and whatnot to become, to be exposed to stresses. They even had this chaos monkey technology, randomly putting the whole system under huge stress and then learning from that and getting stronger and more capable. So the way I see approach to design anti-fragile architecture is to introduce boundaries. And then once we introduce them, we need to maintain them. So the question here is, why boundaries? What's so special about boundaries? When we introduce boundaries, they give us room for trial and error. And because they enable us to work on small problems, the boundaries isolate part of the system. And here we are suddenly given more or lowering the risk of playing around and fooling around and working on smaller problems. When we work on smaller problems, we make small errors. Because if we work on a huge, big problem and the error we make probably propagates and becomes big rather quickly. Nature loves small errors. Small errors are the basis of evolution. And I think in engineering, from what I know, and maybe you disagree with me, most of these like inventions and discoveries are basically imitating Mother Nature and learning from looking at the nature, detecting, seeing some patterns, figuring out, and then we replicate that in our lab. And Agile is like that. Agile is all about small errors and evolving the system, because small means focused. If it's big, if it's complex, it's very hard to focus. It's like your brain is scattered all over the place, and you're trying to find the rhyme and reason and some patterns, and it's like really tough. But if we really have a very modest, small system, then it's easier to focus. And when we have these small errors, they put pressure on the system, but they're not jeopardizing it. It's very important. So we need to be able to put a pressure on our system without actually killing the system. When small errors happen, the small part of the system may stop working. However, the system as a whole keeps functioning. So one good example in my mind to illustrate this is when we go to the gym and we start lifting weights, pumping iron. Now, what's happening at that point, we are putting stress on our muscles, for example, our whatever, right-hand muscle, left-hand muscles, biceps. What's happening at that point, if you look at from the medical standpoint, this pressure and this stress on muscles is causing micro tearing. So some of the fibers in the muscle get broken, they tear, because they just cannot withstand so much weight. And okay, I mean, that sounds alarming. Why would I be tearing my body? But there's boundaries, it's small. And then when we are done with the exercise and we go back and now we are recovering, not only is the muscle healing, those tearings are healing and getting back to the previous healthy state, the muscle grows bigger and stronger. So this is anti-fragile. So under the stress, something breaks, but then when it recovers, it's now more capable. And of course, when the error gets fixed, the system not only goes back to its full functioning, but it becomes stronger than it was before the error. So that's a very attractive, to me, very attractive proposition. When I'm designing systems, I want the systems to grow and become more capable. Boundaries help components take separate evolutionary trajectories, because you may have different parts of the system and each has their own kind of nature, and some of them evolve fast, some of them it doesn't evolve that fast, but they shouldn't be stepping on each other. They should collaborate with each other, while the collaboration is tight, but it allows for various different pace of evolution for different parts of the system. And without boundaries, we can't have that, because we start stepping on each other's toes. Okay, talking about evolution. Here's a cartoon of how allegedly, we evolved from the apes and became more and more sophisticated. And here we are today on the right-hand side, kind of hunched over a little device as the most recent stage of our evolution. So I want to talk a little bit about that. Today, I would say we live in the age of screens. Like previously, we lived in whatever atomic age and the iron, blah, blah, the Stone Age, but now we live in the age of screens. This is my observation. And I see that our lives turned into screens. Everywhere I go, I see this picture. People just hunched over, looking at the screen, not paying attention to anything else. And I'm like this lady, I'm like, I don't understand this. Why is our lives turned into just staring at the screen? And also flabbergasted. I mean, I'm an older guy, right? So I come from the old world. So to me, this is really something I cannot wrap my head around. And also, I don't know if you watched this TV show called The Capture, which I highly recommend, both seasons. It's all about screens and how screens have penetrated our lives and potential danger of putting everything up on the screen. So yeah, if you can watch it, it's really well done. But I think we can do better than that. So, but you see, it's not just the screens. It all started like almost 600 years ago with the invention of the printing press. Because before the printing press, life was completely different. And the invention of printing press, and then what unfolded, really shaped our world. And today we find ourselves at the kind of high end of this process. It took like 500 years, enabled all these phenomenal technological advancements and discoveries and a lot of fantastic things. But we also became a victim of our own success. So it's so successful that it kind of imprisoned us. And we've reduced all our faculties to a small rectangular surface. So this is a flat two-dimensional surface, be it paper or screen, and that's all it is. We now only work in the visual and symbolic realms. So visual, we are looking at the rectangular surface. Symbolic, we are looking at alphanumeric characters, emojis, and some pictures. That's basically our lives. We have completely neglected tactile, aural, kinesthetic, spatial, inactive, and iconic dimensions, which is our real natural faculties that we have developed throughout, I would say, millions of years of hunting, gathering, and evolving. And now we've all just shoved that on the side and just focus on a flat surface. The overwhelming success of printed paper and screens have impoverished our abilities to fully experience and positively transform our reality. So now we're really like a hamster in a cage, just kind of doom scrolling, and that's day in, day out. To me, that's really disturbing. So Agile, I think, is the call to reason. In Agile, we're saying, let's grow out of the tiny rectangular prison and open up to the multidimensional world we live in, because there's so much wealth there, and we can do so much better than just being this hamster in a cage. And we can only do it in an agile way. Why? Because I don't think we can have a master plan. There's no blueprint for how to move forward. The only way to move forward is in a dynamic way, like I say, with experimentation, learning, innovation, trying things out, making small errors, and keep going. Now, there's something called representation of knowledge. That to me is a very important concept, because whatever we choose to represent our knowledge about the world, that thing restricts us and kind of restricts in which direction we can progress. For example, there's a point in time when we've represented our knowledge in Roman numerals. Everybody knows about Roman numerals. And those numerals represent our knowledge of counting. Meaning we use Roman numerals to represent our knowledge of numbers, 1, 2, 3, 4, etc. And we can represent them with symbols, symbolic representation. But Roman numerals restrict our ability to progress and come up with elegant arithmetic and algebra. It's very hard to do arithmetic in Roman numerals and almost impossible to do algebra, at least to my knowledge. For that progress to happen, we had to switch. We had to change to a different representation of numbers, because we were imprisoned. If we stuck with the Roman numerals, the world would be completely different today. We wouldn't have any of this. And so we had to switch to Hindu-Arabic numerals, a completely different way of representing our knowledge of numbers. And that opened up the doors for, let me go back quickly. Open up the doors for all these breakthroughs in science and technology, etc. However, to my mind, the real progress begins when we start combining two or more representations of knowledge, not just sticking to one. So this amalgamation, this ability to experiment and take seemingly unrelated representations of knowledge and then putting them together and see what happens, really is a powerful concept. And I think Agile is all about that. So, for example, there was a point in time when all we did was represent some knowledge about some process in a table. So we have, these old documents where we have your, extent in square miles and then the number. And so this is a table with two columns, right? And that's how we all, for the longest time, we were all like representing our knowledge about something. But then also we were started representing knowledge about territories with drawing maps. So these two are completely unrelated, right? So on one hand, you have table with two columns. On the other hand, we have a map where we draw north, south, on the vertical axis and east, west on the horizontal. And then we plot the territory with boundaries. And both of them are restrictive. They have narrow bandwidth. With a two-column table, okay, this is a narrow bandwidth. We just have numbers and what do they mean? And in the map, narrow bandwidth, just territory. But if we take these two representations and combine them, we get a brand new, richer representation, which I think it's William, what's his name? Sorry, I'll find his name later. So he did that. He said, okay, let me take the map, and instead of having north-south on the vertical axis, I would plot money, and instead of east-west, I would put years and see what happens. And that's how graphs and charts were born. So now, all of a sudden, we have this new breakthrough, which combines the two representations, creates a brand new representation of knowledge, which is much more potent, much more powerful, and communicates information much better, much more effectively. Today, it's a second nature. It completely feels natural to us to open a chart and read and understand exactly what is being represented there. So I'll say the quote from Charles Darwin here. It is not the strongest of the species that survive, nor the most intelligent, but the one most responsive to change. And so Agile here is a discipline that we are striving to adopt. Why? Because we want to be responsive to change. Our world is changing. Oftentimes I read it's called the VUCA world. V stands for volatile, U for uncertain, C for complex, and A for ambiguous. And indeed, wake up every morning, we have no idea what's going to hit the news. The world is in turmoil. And we need to stop being passive. I think we need to jump on and become responsive to change, not going la, 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 or digging our head in the sand, but experimenting, learning, working together, taking small batches, incurring small errors and learning from them. So that ends my presentation. And now over to you, Valentina, for discussion.
Wow, this is like exactly on time. So for the discussion, I will maybe firstly just show some interesting quotes which came up, and also whoever is in the among the viewers, feel free to write any questions on chat. But these are some quotes, and maybe you can elaborate a bit on these topics.
Maxi, hey Maxi, great to see you. Maxi and I were hosting the first international TDD conference last year, and Maxi helped a lot. Fantastic expert. And Maxi and I hosted coding interviews. I had this series of coding interviews where we have people, we record step by step, and it's not for hiring somebody, it's just for illustrating how things will unfold, starting from scratch and solving some problems. So Maxi says quality is free, but only to those who are willing to pay heavily for it. It's a paradoxical statement, free by paying heavily. I mean, in my mind, the heavy price tag is in winning the race with our own incompetence, because we, myself including, we tend to really stick to the familiar and be adverse or allergic to changing anything. Like, why? I mean, here I am, everything's working, I have electricity in my house, and why would I consider changing anything? So that's a big problem when we're trying to reach quality. Is it is not a static thing that, okay, everything is already prearranged and now you have your quality you enjoy. It's a dynamic thing. And there is a saying, whatever got you there keeps you there. If you had to exert yourself to get to a certain point, now if you want to stay there, you have to continue with the exact same, if not even stronger effort. So it's not like, okay, I reached my goal and I'm kicking back and everything's cool. No, that's not how things work. And we like our comfort zone. We like to kick back and take it easy. But again, we live in this VUCA world where it's very volatile and very uncertain, right? So things are uncertain. There's no certainty. Nobody can guarantee anything. And then we see that it's complex, which is maddening, and then it's also ambiguous. So we are communicating, and then we think we have reached a common understanding, but have we? And oftentimes, as Woody Zuhl says, the only way to learn what to work on is to work on it. You cannot have a session prior to your work and decide we're going to work on that. So he advocates, let's start working, and then by doing it, we'll discover what needs to be done. And that's not how we are trained. We are trained to have a nice little blueprint, and then you take it and you just follow the instructions, paint by numbers and connect the dots. But in this new world, I feel like we need to take charge. It's not like you buy your blueprint from here and then execute on it. So I don't know if that answers your question, Maxi.
I think that this is a great commentary regarding this quote, and I guess to add to it, it's even linked to the education system, which is often training people to come up with plans, like the best plan to achieve something, and then you execute it. So there's actually, how should I say that, distinction between planning versus execution. And we also have another quote also from Maxi. I guess this is also related to volatility. So walking on water and developing software from a specification are easy if both are frozen. So maybe you could also talk about that topic as well.
Yeah, it's true. That's why, I have 32 years experience in this profession, and I come from the old world. And yes, that's how we used to do things. We have in-house business analysts and subject matter experts and business people, and then they take their sweet time. And actually, they're mobbing. Even I remember back in the 90s, I was hired to. I was working for the provincial healthcare government institution, and then I was. What's the word? Assigned a project to create an admission, transfer, and discharge of patients in hospitals. And then I was leading, as an engineering lead, I was leading those experts there was like about 50 hospitals, and we would book a boardroom, we would spend the whole day whiteboarding, and everybody in the same room, talking, working on it. This is mobbing. That was back in the 90s. And it wasn't like, okay, everybody goes away and you work on your document. No, we work together. And then if we didn't solve the problem on that day, then we schedule another session. And I was leading those sessions. And so that's fantastic from the perspective of gathering requirements and, ironing some kinks and figuring out. But then, we would freeze those. Eventually we get to a point where everybody says, okay, this is it. And we freeze them. And then it's over to, IT people to implement it. But the problem, of course, is that in the meantime, a lot of things change. And then the water stops being frozen and you crack through the ice and you drown. So, we need to, as I say, develop software not from a frozen specification, but develop it by making small changes and testing them, getting the feedback. That way, we are close to the reality. Like the way Mother Nature evolves is it makes a small change and it sees if it fits or not. And there's some kind of a selection mechanism at work. And same is in our profession. We need some selection. We need some way to confirm or reject the change instead of daydreaming and saying, "Yeah, I know exactly what needs to happen." And I spend 18 months just locked in my room and I'm building everything and I go, ta-da, there it is. And they're like, what is this? This is not even, I don't even recognize this. So yeah, freezing is the old, like it's a static world, the world we are familiar with and that we like and makes us feel cozy and comfortable and everything's reliable, but it doesn't seem to be reflecting the reality. And we continuously, from one catastrophe to the next catastrophe. That's why waterfall lost support, because it's really many waterfall projects really don't go anywhere, and they are like either 10 times more expensive and takes 5 times longer, or they just get kiboshed, like, okay, forget it, cut your losses.
Yeah, exactly. And I mean, the biggest problem, as you mentioned, is the delayed feedback, because it could mean someone is essentially predicting what might be useful for a user, and quite often they might even be distanced away from the user. They are predicting, they're making a huge risk, so much money is spent, and then everyone has to wait a year, or something to get the results. But quite often, due to developer estimates, instead of a year, it could be 5 years, and then it's even worse. So that's a good point. Now we'll get to the next question. I see what a boundary can provide, but what a boundary can provide, but don't really get what it was concretely. Can you clarify it? I'm
Well,
not sure if that.
I think it's a implementational concern, and there's many ways to skin a cat, as the saying goes. So there is no prescribed way to provide boundaries. Some people use microservices. Some people use. There's millions of ways to isolate and compartmentalize and modularize. It's down to the team to decide how to implement the boundaries. They could be physical. They could be logical. Mix of these two. In the brave new world of IoT, the boundary is actually a physical object, right? That has some software running on it. And inside that object, there's maybe other objects, or maybe some. The whole point is that when we're designing systems, we should strive to really build system out of simple, smaller things. The simpler the thing is, the less danger it is for us to over abstract. There's a huge danger in our profession of over abstraction. Waste and becomes a problem. But if and of course, if there's a big problem area, then we go in and we start abstracting, over abstracting. But if it's a small thing, very simple thing, then you can't really do much to over abstract it. It is already simple and it's already kind of abstract. So that's one thing that helps. And I just want to quickly go back to your previous comment, Valentina. For some reason, we've been brought up and taught, and in everyday work, we are always expected to be able to predict the future. There's this expectation that is baked into our way of working. And like if you say, look, I don't have crystal ball, I cannot predict the future, then you come across as somebody who is ignorant or incompetent. But actually, you're being realistic. But it's not still culturally ingrained that we are okay with not being able to predict the future. If somebody hires you and they're paying you good money, hey, they expect you to be able to pretty reliably predict the future and make your estimates and whatnot. Now, this is foolhardy, right? This is just fake, false economy, but it persists. And I see that always people expect from me when they hire me, like, okay, now tell me what's going to. I don't know. I really don't know. I have no idea. We'll see, right? But that's not a very reassuring answer, because they say, hey, anyone can say that. So how are you special compared to somebody who is clueless And by the way, you'll also come across as being a bit close to us. But a real expert will go in with authority, say, yeah, here's what's going to happen, this and this and that, right? And so I think Agile would be a detox from that, like a detox therapy from this insisting that we must be able to predict the future, because we can't. But for some reason, it's making us extremely uncomfortable to admit to ourselves, like, look, we don't know what's going to happen tomorrow. And Agile is the way to deal with that, and to not be feeling like you're in a chaotic situation, right? And that's why we are so basically Agile and the no estimates movement and the mob programming, addressing these things and creating psychological safety, and for people to be in a situation where they completely confidently can say, I have no idea, but I'm willing to try. I'm willing to give it my best shot, and then little by little we'll get to where we want to be.
Yeah, exactly. I guess this whole thing goes back to the uncertainty, and it's about accepting the uncertainty rather than masking the uncertainty through Gantt charts, even though it might be more comforting to the management right now to see the Gantt charts, but there's actually not much value in the future. So we have the next question. I'd like to have cases of Agile applied to activities of other sort than software development, like sports and construction. And it's interesting how Agile relates to these theories, like Christopher's Alexander's architecture theory and practices like SRE. Experimenting mentioned seems to be related to error budget part of SLA to me.
Yeah, definitely. It's not just for software. Definitely. And even, I had a training session, because, when I was working on one project and it was gaining some traction, and it, the word of mouth was traveling. And then a lot of people who are not in software development, they started asking me, so what is this test-driven development? Everybody's talking about this, and you have the dojo, you're running the dojo and running the conference, and what is it? We are really curious. So I prepared for non-technical people, for people who do not have anything to do with code or software. I prepared a course, TDD, for non-technical people, where I created I programmed a small framework that allows people to write prose, like narrative, be it a business plan or proposal or something, and they can first write a test expectation and then see it fail, and then write a document to make the test pass. And in that way, I demonstrated what TDD actually is that you put your expectation in, see it fail, now you're satisfied, now you keep going like that. At the end of the day, you have your system that is actually, you have your regression baked in and is allowing you to add new things without the risk of breaking existing things, and also making sure that at any point in time, if you were to share that and put with another team and they want to review, this TDD process is not just for software. It is anytime we have an expectation that we can somehow formalize, we can have a system that's automatically going to run and verify and let us know if we met the expectation or not. So Christopher Alexander, The Timeless Art of Building, and all these things, fantastic. And they are all about experimenting, learning, innovation, dynamic, and not being stuck in certain finality situation, like this is final, this is it, nothing more to learn. From now on, I just want to see these people just laying bricks, nothing else. Which sadly is a lot of times I join teams, I see they're hired to just lay bricks. Here's your blueprint. I want you to just be laying bricks. And most of the time, people just write so-called glue code. Just gluing some components and, React, blah, blah. That's not innovation, right? They're just like mindless chores. And we see it now, the emergence of these like GitHub Copilot and Code Whisperer and all these things where machines can actually do a lot of that heavy lifting. so that we don't have to do those chores, right? And I'm kind of pretty enthusiastic about that. Um, Although it's very, very early days, right? But we reached a point where machines can do a lot of these like pattern matching and doing the heavy lifting, and free up the time for us to think, to experiment, and to just be down in the weeds and wasting time digging around. As far as how that um, plays out in sports, in construction, in theater, there's another thing I'm really big on, which is OODA pattern, which is observe, orient, decide, and act. And I think these things are also, I didn't have time to put in this presentation, but these things are also really good practice to deal with uncertainties and the VUCA situation. And it applies, it's like pretty much like improv theater, where you are thinking on your feet. And the key point is the ability to disassemble and reassemble your reality to experiment. You take your familiar patterns and you just pick them apart, and then you reassemble it, like we did with the map and the two-column table, and all of a sudden we have a chart. So this is what we need to do. We need to take our familiar representations of knowledge, pick them apart, reassemble them differently, and see if it sticks or not, and keep going like that.
Yes, it comes down to experimentation, and I also liked the example that you gave regarding TDD and having a session for TDD for non-technical business people, because this whole notion of write your expectations before you do anything, even though it's controversial in software development, it's actually pretty much accepted in nearly all other fields.
Oh yeah.
So anyone generally specifies expectations, and people align on expectations before anyone executes. I mean, if we think about anything, marketing plans, financial plans, I've never seen them executing something without firstly specifying what they're expecting from this. And it also reminded me of the story of how I started TDD, which was not through code, but it was actually with Microsoft Word. And it was with a client where there were consistently bug reports, consistent misunderstanding. So then I decided, okay, I will write the test cases first. It was a waterfall project, so I decided to write test cases as part of business analysis. And then later, that was essentially setting up written expectations. So I really related to your story. Now, for the next question, how to manage the size of a small step. For a small step to be presented to the final customer, it might be really big. I think that this is referring to that whole notion of where you had the example of the bread and the butter, and that it was not enough to just serve the bread, like that you had to serve the butter on top. And then the question is, I've noticed this maybe even in some financial applications where they don't want to see like a part of a calculation or something, but they want the whole thing, what they say, working.
Yeah, that's a really, really good point. The size, and again, it's experimentation. If we take this trivial example with the restaurant, let's say I'm super eager. I'm now a big proponent of early feedback, and I'm so eager to get early feedback that I just cut one slice of bread and I rush to the table and say, "Hey, here's one slice of bread." That is meaningless, because the guests will be confused. Like, what do I do with one slice of bread? At least give each of us, and then of course just the bread may not be enough. So we need to have this kind of bounded context where it makes sense, and that size is of course dependent on the use case, on the situation. In this case, like you say, Valentina, maybe a bread basket with some butter is enough. It will get people engaged and they like to try and all that. It buys you some time to go and elaborate on it, but you need to have some kind of acumen or some kind of business knowledge that will make sense to your customers. Um, the question here is also if it's too big, well, then, vertical slicing. If you, and again, sooner, not faster, you're going to focus on one narrow thing. For example, like it described, pay manually. That's your first slice. And then while they're using it, you go and work on paying by credit card or something like that. Right? But if you wait till the entire enchilada is ready, then customers may lose interest, or you may not get enough feedback, and you'll learn that the time invested in this whole cake was kind of not well spent, because they're like, no, we don't want that, right? But if you give them slice by slice, you learn. And also, in this restaurant example, maybe when they were bringing soups after appetizers, maybe somebody says, oh, I forgot to mention that I have allergies to mushrooms, and then they know, like, okay, don't put mushrooms. So it's, early feedback is really good for survival of the business. Otherwise, if they poison the food critic, they wouldn't be getting much of a positive review.
Exactly, and I think another argument which can also be used there is using feedback for purposes for alignment. So even though the final customer says, oh, I don't want this to be officially released and live, but there's nothing preventing us from having certain regular meetings where we show those little slices to the customer, and we would say the purpose of those sessions, we want to make sure that we're on the same page, for our own internal understanding. So that's another, argument, at least, which I've used when I was in companies. Now we have another interesting topic. Alex, in your experience, how to make stakeholders deliver requirements that are small enough to fit into sprints? Many times they just keep it vague and avoid any concretization. User story mapping failed too.
Mm-hmm. So, that's a waterfall, right? Requirements are a hallmark of waterfall. In And sometimes we use them interchangeably, but in Agile, we like to talk about expectations. And by expectations, we mean, what is the desired outcome that the stakeholders bring to us? Now, they must be able to tell us, okay, I would like to see this happen. This is my expectation. I would like this outcome or this impact to materialize. And then we, the team, can take it and we can say, wow, this is bloated, and then we can vertically slice it. So if the stakeholder comes to us and they say, okay, we would like our customers to be able to pay for orders. Pay, it means a lot of things. How about we first give you that they're able to pay manually? Maybe phoning and giving us the credit card number, and then we can punch it in. And then on the next iteration, we will enable, hosted checkout, credit card payment, and then we'll move on to Apple Pay. And so that way we can collaborate with stakeholders and clarify. And because at the end of the day, it is our responsibility to bid on the work. Now, this brings another problem where I'm noticing a lot of teams, myself included, we tend to overbid. This is a very bad habit, but there's something ingrained in engineers that we always are eager to bid more. Oh yeah, sure, I'll take it, and I can also do that. Don't worry, because we feel that way. We feel we're helping, we're important, we like to feel useful, and that is a bad habit, because we should always under-promise and over-deliver. But by overbidding, we overpromise and we underdeliver, and then they lose confidence in us, and like, I don't know. And then micromanaging steps in, and like I say, concretization. They don't necessarily have the knowledge to tell us how to do things. They just want to tell us what they want to see. How we going to do it? It's basically, that's why we are paid big bucks. They don't have to tell us. They don't have to talk to us about which database to use and how many tables and columns and foreign keys. They don't need to know that. But definitely we need to understand what is the expectation. And then the ball is in our court to say, okay, now given these expectations, I can tell you, I can give you this for now, and then later on. So we have that agency to negotiate, and we should, like I say, our strongest weapon right now for the teams is vertical slicing. That is a very strong weapon, and if we know how to do it, we will never be caught over promising, under delivering, and stop overbidding for work. Being realistic is much better than being optimistic. And yeah, I can do all that. Don't worry. And then you spend sleepless nights and weekends, and then after all, you know what? I'm quitting this job. I can't take it anymore. So not good for anyone.
That's a common situation. And the other thing, as you mentioned, the word requirements doesn't really belong with agility, because the whole focus of being agile is to deliver value. So it doesn't say anywhere deliver requirements. It's like delivering value. Now, if stakeholders are specifying as concrete requirements, so instead of saying, okay, the value we expect is maybe, we want to, I don't know, increase sales on our e-commerce by allowing payments, or they might say, we currently are doing order processing in a manual way, we want to automate it. That's, for example, a good way for the customer to approach. But if they say, my requirement is for you to make screens A, B, C, which does this and that, then we're essentially back to waterfall. And it's like you have to deliver all those screens, and that's it, that's the requirement. Yeah, so I think this was definitely a good topic.
Because agile means we are experimenting, which means there's something called validated learning, which means it is a hypothesis-driven development, not requirements-driven development. So I treat those expectations as a hypothesis. So the business comes to me and says, okay, I'm saying you hypothesize that if we make this change, this will be the impact, right? Right. Now, we are going to implement it in such a way to also collect telemetry and to see that from that telemetry, there's something called validated learning. And we will look at it and we will either corroborate your hypothesis or it would be refuted, right? But nobody has a crystal ball, so they don't know. Nobody knows upfront that this change is indeed going to result in this outcome. That is unknown and is uncertain. And our job is to work with the business, collaborate to step by step discover what is the next thing to do. We try this, we try that. So that's agile. And for that, we need to be delivering sooner, not faster, right? So the sooner we deliver, the sooner we learn, the sooner we correct the course, we interrupt. And instead of waterfall, where it's just like frozen, it just goes straight. There's no interruption, nothing, just go, hit the bang, and then see what happens next.
Yeah, exactly. Now, the next interesting comment: isn't ODA a strategy for destroying stuff rather than building it? Though pro-US military also used quite interestingly in recent political maneuvers here in UK, so it works well for tearing things down, but it needs other strategies and techniques to build something better afterwards. What are your perspectives regarding this comment?
Sadly, sadly, pretty much any breakthrough in technology is always seems to be associated with war and with killing and destruction. For some reason, that duress when we are in war, either Cold War or hot war, puts a lot of strain and there's a lot of investing in scientific research and technology and all that. So we probably wouldn't have computers today if it wasn't for World War II, where and all these things. So yes, sadly, it's always the high price to pay for the progress is destruction and killing. But also, I don't see ODA being in any shape or form restricted to that. You can use it for constructive things. You just observe. Then when you collect empirical evidence, you can disassemble it and reassemble it, orient. Then you decide what to do next, and that decision could be positive, and then you act. And then from your action, you will generate new empirical evidence, which loops back into your orientation. So nothing says in ODA that it must be destructive or negative. It is what it is. You are going through reality empirically, observing, and then you are using your ingenuity as a team to disassemble your observed evidence and reassemble it in new ways and experiment. Decide what do we do next? Okay, now given this and that, blah, and it could be really breakthroughs in COVID vaccine, or millions of positive things can happen in ODA fashion.
It's about being adaptive, which is different. So the technique is essentially being adaptive, but the way that people may choose it differs upon someone's purpose. Now, so thanks everyone for your questions. Since we've reached the end, I just want to show this thank you note. So this is really a nice comment. This resonates with the viewers' experiences, and another one. So I think that this is really great, to see the impact from this meetup session. And that even people can rewatch it afterwards, because there was a lot of, I guess, new concepts to digest here. Well, I mean, old concepts, but being brought back in a more understandable and more visual way. So yeah, I just wanted to say I really enjoyed this whole presentation and the way that you explained everything, and it was great that we got excellent also feedback from our viewers. So yeah, I just want to say thanks a lot.
And thank you for putting up with me and enduring my lame analogies and stories. And oftentimes people say, why are you always using analogies? But I have no other better way to.
I actually like analogies as well, and visualization. I think it's more effective for communicating concepts and memorable as well.
But keep in mind, they can be stretched too much, and then they become the counterexample. So always you keep them with a grain of salt. They from here to here they work, and then you don't just push them on everything, right? So
yeah,
but it's a good thing for a casual presentation or chat.
Exactly. Yeah. So thanks a lot, and also in our description we will have links to your LinkedIn profile, so that people can feel free, to connect and to follow your content. I mean,
let's continue the discussion. Yeah.
Yeah, definitely. So thanks a lot, everyone, and have a good day. Bye.
Thank you. Bye.